kind of problem, that's your first problem. I give you a table with the angles 0, 30, 45, 60, 90, and I have 2 blank columns for sine and cosine of those angles. And you fill them in. There's your first question on your test. I don't know how to do that, but what the hey, let's enable it. Usually when you subtitle in math, it really looks bizarre. Or, you know, when you get those transcribed phone messages and it looks nothing like what the phone message is.
Yeah.
Yeah,
They do just call math on the transcript.
yeah, yeah. So there we have it. Now I have to watch my language. I can literally watch my language. Bada bing.
How long is the test gonna be, like, how many questions?
I don't know, how many questions can you do in an hour and 20 minutes? Well, if you want 5 questions at 20 points each, I can do that. I never count the questions, I just put them on there. I try to make it cover everything that I put on the review sheet, the important things. Well, that's your first question, so I done gave you that one. So you need to know, I've outlined things on the review sheet, so you need to know that kind of stuff. You need to work with degrees, minutes, seconds. You need to convert to decimals, but it'll be easy division. So I'm not going to make you do something terribly hard. I'm trying to pick numbers that most of us can do. So just, I don't know. Just I'll make enough problems so that they're not worth too many points, but also so that we're out of here in, say, about an hour and 10 minutes max, and then another 10 minutes for the fudge factor. Okay, so. Okay, so for you folks at home, if you are socially isolating and cannot attend class on Thursday, then please email me so that I have a way to proctor your exam. Those of you who have the special accommodations, you'll be taking the test in the testing center in West Hall. So don't show up here at class time, go to West Hall. Okay, to the testing center. Those of you with special accommodations already filled out the form, brought the form to me, acknowledged it. You're to take the test at the testing center in West Hall, so don't come here. You won't need anything but your pencil and maybe a couple sheets of paper for the short answer problems. I'm going to try to minimize the amount of paper that I have to print. So for the short answer problems, you'll work at it on your notebook paper and I'll staple them together. Okay, so I have some questions on some web work. Let's take a look at web work. Since I don't have it printed, and I'm afraid to look at it on here, I'm going to have to make it up. I'm going to work problem 10 first because I do have a copy of that one. Everybody has different numbers for problem 10. So I'm sorry if I don't use your numbers. Let me see where I put it. I believe problem 10 is the one where you're trying to find the height of the tower. And a person walks toward the tower. Initially, the angle of elevation to the tower is given. Then the person walks a certain distance closer to the tower. Another angle of elevation is given, and you're supposed to use that to find the height of the tower. So I'm just going to make up a couple of angles. A person observes a tower a certain distance away. The angle of elevation to the top of the tower I don't know, let's just go with a nice angle. Let's go with 60 degrees. The person walks 112 feet closer. And now the angle of elevation to the top of the tower is, again, I'm just making these numbers up, 65 degrees. Find the height of the tower. So a diagram of what's going on is person standing here, off in the distance is the tower. Initially, the angle of elevation, again measured from the horizontal elevation, is 60 degrees. They walk 112 feet closer to say this point. Then the angle of elevation changes to 65 degrees. Find the height of the tower. Okay, I'll have to answer that in a second. So we have two right triangles here. We have this small right triangle with the 65-degree angle. And then we have the large right triangle with the 60-degree angle. In the small right triangle, if I'm going to use a trig function and the 65-degree angle, it would be helpful to know the value of this leg. But we don't, so let's use a variable right there. So I'm going to put an A right there. And then I'm going to use a tangent function to give me the ratio of those two sides. So the first thing I'm going to say is that the tangent of 65 degrees is T divided by A. There are two things that I don't know that's getting in the way of me solving this problem. Firstly, of course, is T. Second is A. If you have two unknowns in a problem, it's helpful to have two equations that relate those two unknowns. So there's one of them. The second equation is going to come from the big triangle and the fact that this leg has a length of 112 plus A. So now I'm going to use a tangent of the 60-degree angle and opposite over adjacent. So my second equation looks like the tangent of 60 degrees is equal to opposite over adjacent. The tangent of 65 degrees is a number that if you had your calculator, you can get. The tangent of 60 degrees, though, is a number that you know from the table of known values. Who knows that one? Tangent of 60 degrees. That one is the square root of 3. So I'm going to put that in there at this stage, that this number here is the square root of 3. And then I'm going to multiply both sides by the A plus 112. And there's an expression for T. The first equation up here, if I solve it for t, says that the tangent of 65 times a is equal to t. I think what I'm going to do is solve these two equations by substitution. I'm going to take the top equation and write a in terms of t. I'm going to put that in where the a is in the second equation so that I have one equation that has a t in it. So from the first equation, I'm going to say a is equal to t divided by the tangent of 65 degrees. I'm going to substitute that in right here. So that's going to give me an equation that has only the variable t in it. And I'm going to put that over here somewhere. It'll look like the square root of 3 times t divided by the tangent of 65 degrees plus that 112 is equal to t. I'm going to multiply the left-hand side out, and then I'm going to put the t's on the same side of the equal sign. So here, I'll just have the square root of 3 times t over the tangent of 65 degrees. Here, I'm going to have 112 times the square root of 3 is equal to t. Now I'm going to take this term that's added over here, move it to the other side by subtracting it. And so my equation will look like 112 square root of 3 is equal to t minus the square root of 3t over the tangent of 65 degrees. Maybe this is a good time to go to a decimal. Okay, the algebra in here will look messy if I leave it in terms of the expression. What I think I'm going to do is go ahead and figure out what number this is. The square root of 3 divided by the tangent of 65. Write this as a decimal multiple of t, and then we'll take it away from 1t. So I'm going to take the square root of 3 and divide it by the tangent of 65. And I'm going to keep about 5 decimal places. So I have 112 square root of 3 is equal to t minus 0.807. Let's make that 67t. 80767t. This is 1t right here. I'm subtracting 0.8 of those. So on my calculator, I'm just going to take 1 minus that 0.807. And I get, see where I can write this, it still fits. 112 square root of 3 is equal to 0.19233, 1, 2, 3, 4, 5. Let's stop right there, times t. And so now I just divide both sides by that number in front of t. So let's carefully get that off the calculator. That number looks familiar, so I maybe made this up. So I'm getting this many feet right here. Typically, when there are no decimals in the problem, you give your answer to the nearest whole number. But some of these WebWorks ask for your decimal to the 100th place. That's not going to be a problem for us on the test because we're not using calculators. I won't give you a problem this messy. But one of the things I'm noticing is when you do these things, you're making a mistake in rounding way too early. So I tried not to round very much. This particular problem is pretty sensitive to your rounding. So you may have done all the steps correctly, but you kind of threw away too much precision. Yes, sir.
This problem was also on review,
Was it?
so are we gonna get some sort of problem like this where we don't have a full leg of the triangle?
Maybe I'll have you set it up or something. I don't know. I'll try to figure that out. I'll try to make it so that it's more user friendly to people without calculators. I'll try. I make no promises. Yes, sir.
Where would we stop on the test for that?
Oh, well, on the test, you would leave all this stuff here, and then you'd factor out the t and divide by, right? If you did this step on the test, you just factor the t out from the right-hand side. I don't want to mess up this page. Let me go to another page. You, at this step in the problem, at that step in the problem, you'd factor out the common factor of t. And you'd have a 1 in that slot and that funky number over here. And then you divide by the stuff in the parentheses. But like I said, I'm afraid too many of you would freak out if this is the way you had to write your answer. I don't want to scare you away on the first test. I'll try to make something a little bit more usable. Okay. Thank you, Sky, for the answer to that question, but that's true. Our test is here in the classroom. There's a handful of you that have submitted special accommodation forms at the beginning of the semester. If you have a special accommodation form submitted and are to take the test in the testing center, only that handful of people are going to the testing center. Everybody else is coming here. Yes. Problem 7, do you happen to have it written out or in front of you?
Yeah.
I'll-
They should work at the same time.
Okay.
The first ship sailed at a bearing of 120. That's the base knot. And then the second is bearing of 210 at a speed of 17.
Okay. And what else?
That's it.
No, we're supposed to find the distance a certain time later.
How far apart are they after 2 hours?
Okay, so find the distance between them after 2 hours. So firstly, these knots are nautical miles per hour. So treat them as miles per hour. If this ship is going at 18 miles per hour for 2 hours, how many miles has it traveled? 36 miles, 2 times 18, and then 2 times 17 is going to be 34 miles. So that's the first note. Ship A will have traveled 36 miles, ship B will have traveled 34 miles. Okay, so when bearings are given as a single number, Then we measure that angle from a north pointing ray. And we measure that angle in a clockwise direction. So starting at the same port means I'm going to measure both angles from that point here. There's my north pointing ray. Now I'm going to draw an angle of 120 degrees. So 120 degrees is what, 30 degrees more than 90 degrees? 90 degrees makes the right angle. So let's go about right here for 120 degrees. Then we're going to draw a ray from there that's 36 miles long. So it'll represent 36 miles. Let's put ship A right here. That's 36 miles. Now we're going to do the same thing for ship B. Ship B is going to move from that first north pointing ray at an angle of 210 degrees. So a straight line has 180 degrees. I need to go about 30 degrees more than the 180 degree straight line. So if I measure from here, that takes me to the straight line, and about 30 degrees more might be about right there. So this ray is going to be 34 units long. And this inside angle here was the 210 degrees. There's my red pen. That angle's 210. And now we're asked to find the distance between ships A and B. So we're asked to find the length of segment AB. I'll put a variable there. So I want somebody to convince me that this angle of triangle, let's call the port P, APB, can you tell me why there's a right angle at angle P?
10 minus 120.
Yeah. So angle P in triangle APB is a right angle because that 210 degrees takes us 120 degrees too much inside that right triangle. 210 minus 120 gives me that this is a right angle right here. So this description of the ships moving generates a right triangle, and we're looking for the length of the hypotenuse of the right triangle. In a right triangle, leg squared plus leg squared is hypotenuse squared. So we're now using the Pythagorean theorem. Leg squared plus leg squared is hypotenuse squared. And so for me on a test, here's how you leave it. Okay, on the web work, give whatever number of decimal place accuracy is asked. I think this might be one that has the 2 decimal places in the instructions. Yes. Number 6. Okay, I'm going to need you to describe for me problem number 6. Okay, so can you give me the wingspan again? 64.4 meters. And it passes over an observer. And when the observer looks up from wing to wing, it makes an angle of 1.3 degrees. And we want to know how high is the plane? So if I remember right, the picture looked something like, let's see if I can get this little stag off of here. There we go. The picture looks something like this, that you had wing to wing. That part there was the 64.4. Then there's an observer down here, smack dab in the middle, so that this entire angle was the 1.3 degrees. And the height then of the plane, I'll draw as this dotted red line. And so we're going to just use half of the picture so that we can use our right triangle trigonometry. So we're going to cut that picture in half. That means I need to divide 64.4 by 2. And I'll get 32.2. I need to cut that 1.3 degrees into 2 equal parts. So this angle is 0.65 degrees. And then we're asked to find how high is that plane. You agree with that? If you do, then you have the opposite and the adjacent sides. And so we can use a tangent function. The tangent of that 0.65 degrees is 32.2 divided by h. 0.65. So I'm going to solve for h by first multiplying both sides by h. Let me put a 0 here so I don't lose my decimal. And then we'll divide by that tangent of 0.65. Okay. There's no need for a Scantron. I'm going to print the test on a piece of paper. No Scantron. No Scantron, no calculator. You, your brain, and a pencil. Maybe a couple sheets of paper. Don't leave your brain at home.
Did you always put the denominator on the other side of the tangent?
Do I always put the denominator on the other side of the tangent? I'm trying to solve for h. And h happens to be in the denominator, so I multiply both sides by h to get it out of the denominator. And then once it's out of the denominator, I can easily solve for it. Yes? No, you could have done the same problem with a cotangent, right? So the only reason I'm using sine, cosine, and tangent is most calculators have only those 3 functions on them. So just to make it easier for you to do your web work, but you're welcome to use all 6 trig functions you have at your disposal. If you want to make a few of them up, go for it. Yes? Which one on the review? 19 on the review. Well, I don't have anything labeled, do I? Did you get anything labeled on number 19? My paper doesn't have anything on number 19. Is that what yours look like?
Mine had numbers.
You had numbers? Where did your numbers go?
19 is the same question as 10. It's homework problems.
Oh, I don't know why mine didn't. So there's like another distance out here somewhere?
Yeah.
And there were 2 angles? Okay, so let's do that. I guess mine got chopped off, or I got a version that I didn't save. Okay, what were the angles? Which was this angle given? 49? What about this littler angle? 30? Where else did I have numbers? Here? How much? 40 even? Right there? Okay, so let's see if we can solve this problem. This is very similar to the first web work problem that I did, web work problem number 10, where we're going to have to write this with putting a value here. And we've got two unknowns. So it looks like when I solved this on the key, I did not use any calculator. So let me show you how we can do this without a calculator. We're going to write the tangent of both of those angles. Let's start with the smallest triangle and the larger of the two angles. We have that the tangent of 49 degrees is h over a. The larger triangle has this leg equal to a plus 40. And so the tangent of 30 degrees is h over a plus 40. "30 degrees is one of our reference angles. Do we know the tangent of 30 degrees? Square root of 3 over 3, because the sine of 30 degrees is the square root of 3 over 2. The cosine of 30 degrees is, nope, sine of 30 degrees is 1/2. Cosine of 30 degrees is square root of 3 over 2. And so when you flip and multiply, that's going to simplify for you. 1/2 times 2 over the square root of 3 simplifies to 1 over the square root of 3. Or if you want to rationalize that, that's the square root of 3 over 3. So this number we know, let's put it in there. So we have the situation that we had a minute ago. We have two equations and two unknowns. 40, thank you. So I'm going to take one of the equations and solve it for a in terms of h. Put that in for the a in the other equation. But first I'm going to get these all on the same line. Yes? No, you don't. I'm going to write these so that they're on the same line. So I'm going to multiply this side by a. Here I'm just going to cross multiply like that. So I'm going to have a times the tangent of 49 degrees is equal to h. And this equation says the square root of 3 times a plus 40 is equal to 3h. And what we did last time is we took this shorter equation and wrote a in terms of h. So I'll do it again. I'll write a as h over the tangent of 49 degrees. Then I'm going to take that and put it in where the a is in the second equation. And now my second equation will have only h's in it. I'm going to have the square root of 3 times h over the tangent of 49 degrees plus the 40 is equal to 3 times h. Then we could multiply through by the square root of 3 and get rid of those parentheses. So I can write the left-hand side is the square root of 3h divided by the tangent of 49 degrees. Then distribute the square root of 3 here to get 40 times the square root of 3 is equal to 3h. I'm going to get the h's together by subtracting this from both sides. And that leaves me with 40 square root of 3 on the left, 3h minus square root of 3. I'm going to make a square root of that. Square root of 3 h over the tangent of 49 degrees. I'm going to factor out the common factor of h. And that leaves me 3 minus the square root of 3 over the tangent of 49 degrees. Thank you. And then I'm going to divide by that stuff in the parentheses, and h is by itself. Okay. So now that we've done that problem like 3 or 4 times, so now it looks like something you can handle, doesn't it? Yes, ma'am. Yeah, that's the same. If you factored out a square root of 3, you'd get the same thing. Yeah, if you take both of these answers on the calculator, they're equivalent. Yes. No, I just slip that in there every now and then just to get you a little extra practice. So if you've got numbers on web work that are not reference angles, either leave it in terms of that angle, or to make it easier for you to do the steps, give a decimal on your calculator. Okay? Yes, sir. 17 on the review. Okay, so here's 17 on the review. From a window 30 feet above the street, the angle of elevation to the top of the building across the street is 50 degrees. The angle of depression to the base of the building is 20 degrees. Find the distance between the two buildings, and then find the height of the building across the street. See if I can fold that up a little bit. All right, let me try to draw this. We've got one building over here. There's the street. There's the other building. From a window 30 feet above the street, so let's put our window here, and that's 30 feet. The angle of elevation, so the angle of elevation is measured from a horizontal. This angle then right here to the top of the building is 50 degrees. The angle of depression to the base of the building, that angle here is 20 degrees. And our task is to find the distance between the two buildings, that dotted line there, let's call it X. And then find the height of the building across the street. So let's call the height of the building H. So we make the assumption that this is a level ground here. So it's parallel to this dotted line that's horizontal. That means that this piece of the triangle across the street, which is a right triangle, has a leg of 30 feet. So in this small triangle, I know an interior angle, and I know one of the lengths of the legs. I can find the length of X. The 20 degrees is related to the 30 and the X as the opposite and the adjacent. And so I can use a tangent function. So let's write that the tangent of 20 degrees is 30 divided by X. And we're going to solve this for x. So we multiply both sides by x. And then divide by the tangent of 20 degrees. All right, so I said that's about 82 feet. This is where you would leave it on a test. But now we can do the whole thing again. We know this number right here. So I'm going to use the 82 feet. And then I'm going to find this number here using a tangent. And what I know about y is that y is h minus 30, or y plus 30 is h. So my next equation is going to say the tangent of 50 degrees is opposite over adjacent. So when I solve that for y, I get 82 times the tangent of 50 degrees is y. And now final answer has that h is y plus 30. So I take that 82 tan 50 and I add 30 to it. And so where I have that 82, you could have used this number here to get the number that I have on the solutions. Yes,
Problem 11 on web work.
problem 11 on web work. All right, do you want to help me out with it? It's-
Airplane is flying at the height of 7.8
Is that miles, kilometers?
kilometers.
Okay,
You can see both city 1 and city 2 straight ahead. The angle of depression for city 1 is 40 and the city 2 is 28.
28.
Yes. And that times this.
So there's a plane up here and it's looking ahead and it sees the two cities with those angles of depression. And from that, we can measure the distance between the two cities. So let's put a plane 7.8 kilometer. So here's our plane. Put our two cities down here on the ground. There's city number 1. There's city number 2. The angle of depression is measured from the horizontal that the plane makes with looking down. So we're going to measure our angle of depression from here. So down to city 1, the angle of depression is 40 degrees. And looking down to city 2, the angle of depression is 28 degrees. And then we want to find the distance between the two cities. So we have two right triangles. We have this right triangle here. Where this angle is 40 degrees. And then we have the bigger right triangle. Where this angle up here is 28 degrees. So I drew them like that so that you can tell me what the measures of the interior angles at point P are for each of those. What's the measure of the angle in my top triangle? 50 degrees, this makes a right angle here. So this interior angle is 50 degrees. And then 90 minus 28 is 62 degrees. If I agree with that? And so if I find the length here, let's call that A, and then find the length here, that would be B, then we could get X by taking B minus A. Sound like a plan? All right, let's do it. From the top triangle, let's see, I've got opposite and adjacent. Looks like we're going to use a tangent function again. Tangent of 50 degrees is A divided by 7.8. So we solve that for A by multiplying both sides by 7.8. Now do the same thing for the variable B and that larger triangle. Again, it's opposite over adjacent, so we're looking for a tangent. Tangent of 62 degrees is equal to B divided by 7.8. So 7.8 tangent of 62 degrees is equal to B. And then to get X, the distance between city 1 and city 2, take the bigger number minus the smaller number. So 7.8 tangent of 62 degrees minus 7.8 tangent of 50 degrees. So the key here was drawing the angle of depression correctly. The angle of depression, again, measured from the horizontal. It's not going to be the interior angles of the triangles. All our angles of elevation and depression are measured from horizontal lines. What else?
So is that how we would leave it? then?
Exactly, right?
And
We
I know
just,
this is a stupid question, but can you show me how you got to 62 and the 50 degree in one number?
these exterior angles, these angles of depression,
Right.
make a right angle with this.
Okay.
So I just subtracted from 90.
Okay.
So 90 minus 40 gave us the 50, 90 minus 28 gave us the 62. What else? Got nothing for me? All right, I'm ready. I don't know where the voice is coming from.
Web work number 9.
Web work number 9. Can you kind of read it to me? Okay, so the key here is A and B are on a straight line. B is east of A. And so we're going to draw that line segment where A and B are the endpoints of the line segment. B is east of A, and then we're going to draw these bearings, and we're going to figure out how far the plane is. So. Okay, so let's see. Here's my line segment. B is east of A. And when bearings are given in this way, you draw, in this case, a south-facing ray from point A, and then from that ray, an angle of measure 53 degrees in the direction of east. So here's my south-facing ray from point A. Now from there, I'm going east 53 degrees. So like that. So A can view the plane flying along that ray. Now we do the same thing. Draw a south-facing ray from point B. And now you're going to draw an angle in the direction of west from that ray of measure 57 degrees. So draw that ray, and your two rays will intersect, and where they intersect is where the plane is. And the only other measurement we have is the length between A and B is 1.25 miles. The question is, how far is the plane from which point? Point A? So we want this length over here. Are you with me? Now, neither of those angles from the bearings are interior angles of the triangle, but both of those angles make a right angle with that east-west line between A and B. So,
Sorry, excuse me, Michelle.
yes,
The video is frozen.
the video is frozen. On what? What do you see?
We can see the complete triangle now.
Can you see web work problem number 9?
Yes.
So maybe it was just a little bit of
Yeah.
black.
We see it, but it jumps in every maybe like 30 seconds.
It's probably just a slow internet connection. It's lagging.
That's that online learning stuff.
It's the way of the future, I guess.
Yeah, I have no control over that. There's nothing I can do from here, but I'll try to say what I'm writing. And if you don't see it, it'll be on the video at the end of the class. You can just run back to it.
Could it be just like, since you're not moving anything on the camera, like it's frozen? Right. Try to put your hand on.
I don't know. I'm just going to keep going on. And if there are things that you miss at home, you'll just have to run the video back after I post it on Blackboard, because I have no control over any kind of lag. Okay, you guys were going to tell me what the measures of the interior angles are. For instance, 53 degrees is an exterior angle for this angle A. But I said that this angle that from the south facing line and the east-west line makes a 90-degree angle. So we should be able to find this angle A inside the triangle by subtracting 53 degrees from 90. Thank you. Similarly, on the other side, that 57 degrees at angle, the exterior angle B, should add up to 90 in here. So this will be 33 degrees. Did I copy those angles down correctly? Because that does not give us a right triangle. Who called out this problem? Are these the angles that you gave me? The 53 and the 57? Can you check that one more time?
Oh, so, okay, 37.
37, that helps. Let's all change the 57 here to 37. Because in our problems, we need to have a right triangle. So if this is a 37-degree angle out here, then 90 minus 37 is 53. And what do you notice about these two angles now? They add up to 90. So if they add up to 90, that guy has to be 90 degrees right there. So you've got to kind of look out for that. We only have right triangle trigonometry at our disposal. These angles should measure up to give us a right angle somewhere in our picture. Otherwise, we don't have any tools just yet to find the sides.
Which also means that to check it, it would all add up to 180 on the inside.
Correct. We want our 180 degrees on the inside. So that means you've got to be careful in drawing your bearings and things like that. All right, so I do have a right angle. That makes the 1.25 a hypotenuse measurement, and X is a leg measurement, depending on which angle I want to use. If I use 37 degrees, I can find X using a sine function. If I use the 53 degrees, I can find X using a cosine, sorry, I said it backwards. 37 would be a cosine function, 53 degrees would be a sine function. So it doesn't matter. I'm going to use the 37 degrees, and there I have adjacent and hypotenuse. So the cosine of 37 degrees is equal to the adjacent over the hypotenuse, X over 1.25. And so multiply both sides by 1.25, and we have X. Okay.
And that's what we were we stopped.
Yeah, I mean, we're not gonna have calculators, so we have no choice but to stop there. Yes,
Are we allowed to go both ways, the sine and cosine?
sure, because they're cofunctions, right? The cosine of 37 degrees is equal to the sine of what angle? Suppose this were a test question. The cosine of 37 degrees is equal to the sine of what angle? It would be 53 degrees because they are cofunctions. The cosine of whatever angle is equal to the sine of 90 minus that angle and vice versa.
And is it always whatever, like the cosine, like the cotangent?
Right, right. So the name gives it away. Tangent and cotangent related this way. Secant and cosecant are related this way. Okay. Yes. Question 13 on the review. Let's do that. Let's do that. Review sheet problem number 13. 13. We're supposed to give exact values of these trig functions. The first one is the sine of 405 degrees. So what we need to know how to do is determine the quadrant in which an angle of the given measure has its terminal side. Once we know the quadrant, we know whether the trig function is positive or negative. Then we need to find the reference angle. The sine of that reference angle with the appropriate plus or minus is the value of the sine of 405 degrees. So we see the 405 degrees is larger than 360 degrees. Let's take a lap of the circle out of there by subtracting 360 degrees. That means once I take off one whole lap of 360 degrees and go 45 degrees more, I have the same angle as the 405 degree angle. So the terminal side of the 405 degree angle is in quadrant 1. Right? I'm measuring here to here is 360 degrees and then 45 degrees more. And there's our 405 degree angle. In quadrant 1, all 6 trig functions are positive. So I know that my answer has to be positive. And it's the same as the sine of 45 degrees. That's a value that I have memorized. Do you? Square root of 2 over 2. So far, so good? All right, let's look at part B. In part B, I am asking for cosine of 930 degrees. So that looks like it's gone around the circle several times. Let's see how many 360s we can take out of here. So let's take out minus 360. So that leaves me 570. Let's take out another one. I'm at 210. So it is co-terminal with a 210 degree angle after I remove 2 laps around the circle. Can anybody tell me the quadrant in which a 210 degree angle is? Quadrant 3, because a straight line is 180 degrees. Here to here is 180 degrees. 3/4 around the circle is 270 degrees. So it's going to be down in here in quadrant 3. In quadrant 3, only 2 trig functions are positive. Which 2 trig functions are positive in quadrant 3? Tangent and cotangent. So I know my answer here is going to be a negative number. Now I need the reference angle. I've got my angle of measure 210 degrees. The reference angle is measured as the angle distance between the 210 degrees and the nearest x-axis. The nearest x-axis corresponds to 180 degrees. So what angle of spread is there between those 2 angles? 30 degrees. So then I'm going to find the cosine of 30 degrees, then put a minus on it, and that'll be the cosine of 930 degrees. Who knows the cosine of 30 degrees? It's square root of 3 over 2. So my answer here is negative, square root of 3 over 2. Part C, we want the tangent of 120 degrees. Come on, papers. Okay, so that's a number already smaller than 360. We should be able to locate it. Remember, the straight line from 0 degrees to the negative x-axis makes 180 degrees. So that 120 should be just short of making a straight line for us. So this is in quadrant 2. It's just short of the 180 degrees by how much? 60 degrees. So I want to find the tangent of 60 degrees. And in quadrant 2, the tangent is positive or negative? It is negative. So I'm going to put a negative here. To get the tangent of 60 degrees, we need to know the sine of 60 degrees and the cosine of 60 degrees. What is the sine of 60 degrees? Square root of 3 over 2. That means the cosine has to be a half, right? And the halves will cancel. And so our final value here is negative square root of 3. All right, three more. Part D. We want the secant of a negative 240 degrees. So this time we're wrapping that angle. Yes.
Before we proceed. On where you did sine over cosine of 60,
Yes.
if we memorize what tangent already is,
Oh, that's fine.
do we do,
That's
we don't
fine.
have to show that work?
Right.
then?
Yeah, if you can go from here to here, I'm happy.
Okay, all right.
I'm happy.
sounds good.
To get the 240 degree angle, we need to wrap this ray around the origin in a clockwise manner. So if I start out at 0 degrees, this would be negative 90 degrees. This is negative 180, and this is negative 270. That's telling me that negative 240 degrees is going to be in quadrant number 2. About right there. So we're measuring its distance between the nearest x-axis. How far apart are the 240 and the 180? That's 60 degrees. So that's our reference angle. So we need the secant of 60 degrees in quadrant 2. Sine and cosecant are positive. So here, this is going to be a negative number. The secant is the reciprocal of the cosine. So I'm going to put the cosine of 60 degrees down there underneath the 1. What is the cosine of 60 degrees? It is 1/2. So I have negative 1 divided by 1/2, and that's just going to be a negative 2. It's kind of fun, isn't it? How do you know when to give me the, how you need the reference angle in order to find the exact values? So when I say find the exact value, if you just jump from here to here and get it right, I'm good. But if you get it wrong, I can't give you partial credit. So if the more work you show me, the better. Part E, the cotangent of 675 degrees. Now, one thing you may have noticed is that, maybe it was you who told me that, when an angle ends in a 5, its reference angle has to be some version of 45 degrees, right? That's the only one who can have a reference angle of 45 degrees. So this one, I just need to know the cotangent of 45 degrees and decide whether I'm in quadrant 1, 2, 3, or 4. right? So I'm leaving a blank here until we decide what quadrant that's in. Since that's bigger than 360, I just start taking out 360s. So 675 minus 360 gives me 315 degrees. Which quadrant is that? That is quadrant 4. In quadrant 4, cosine and secant are positive, so cotangent is going to be negative. At 45 degrees, cotangent is cosine over the sine, and at 45 degrees, cosine and sine are the same. So this number is going to be a 1. Over here, it's going to give me then a negative 1. Okay. Then in part F, where to go? I'm looking for the cosecant of a negative 420 degrees. Okay, so that's more than one lap around the circle. That's bigger than a negative 360. So let's take a 360 out of there. And it looks like 60 degrees. And that's going to be a negative 60 degrees. Negative 60 degrees is in which quadrant? It's in quadrant 4. And so if that's an acute angle, then its reference angle is just going to be the 60 degrees, right? Quadrant 4. Cosecant is positive or negative in quadrant 4?
Negative.
So I'm going to put a minus sign there. Cosecant is also 1 over the sine. And now I need to know the sine of 60 degrees. It is the square root of 3 over 2. So that's negative 2 over the square root of 3, or negative 2 square root of 3 over 3. I don't care which way you leave it. Okay. How long does it take you to do problems like this? Give me some idea how long to make your test. About 10 minutes? That's about what I took, huh? What else you got for me? How you feeling about this material? Because what part scares you? This kind of thing? Just memorizing it. If you practice, memorizing is practice. It's like free throw shooting. This part here. But I'm asking you to get 100%. Okay, so try to work your way through the topics of each section. For those of you without your textbook, in addition to the review sheet, I scanned the review sections of the textbook, and they're on Blackboard if you want more problems to practice. So when you come to class on Thursday, I'd like you to put your backpacks under your seat so that folks can get in and out of the aisles if somebody has to leave or if somebody has a question. Make sure that you write on your test which row you're in, and then we'll get them back to you a little bit better. If anybody has any questions, I'll stick around a bit. Any questions for you guys at home?
Submitted the disability thing already, but I didn't get no paper to give to no one. So do I just need to call them?
You brought me a paper and I signed off on it, put the test dates on it.
No.
I thought I did.
I know you put the test dates and everything, but I didn't know there was a formal paper we had to bring. Because they didn't.
The paper you brought to me to sign was that formal paper.
Okay. So do I
Did you
just
turn it
schedule
back into the testing center?
I never received the paper from them. I just talked to you about it in.
You might want to check with them to see if you're registered as a test taker there.
Okay, then just email them and talk to them, and if I'm not, do I just come here in class? Or-
I guess if you need a quiet place, I can put you in my office. You can come to my
My
office,
biggest thing is large print and extended time. I get time and a half. I
right?
don't know if that would be a thing that would be able to do if they can't get me in the testing
Then
center.
you can do that in my office.
Okay, all
So
right.
whatever you find out, send me an email, let me know.
Yes, ma'am.
Let
Thank
me
you
go
so
ahead
much.
and end this transcript here so they don't.
Do you have another class after this, like another tree class right after this one?
I have a tree class at 2 o'clock.
So is this room occupied by another?
It
professor?
is. This room is occupied by somebody else.
So we're cut off at an hour and 20 minutes then. That was my question.
That's correct.
Because I'm gonna take.
That's correct. You use your time and that's all the time you get.
I just wanted to know your office hours.
I've got a break right now. Let me get out of this Zoom somehow. This didn't give me a quit option. Get out of this classroom and get out of their way.